Yeah. So, hello everyone. Um, uh, Hopefully, while I'm presenting these slides, you have more audience. I'm going to start the presentation, but before that, I just wanted to note that we have a website for this tutorial, and then we include all the reading material that we are going to cover in this tutorial. Any additional reading papers and etc. up until these links to the slides and the video recording. So that's one thing, and now I can start. So good morning. Okay. So we are here to present our work on team recommendation from the historical subgraph optimization toward the nowadays graph neural network. But before I start the actual presentation, because this tutorial is in an IR conference, we receive a lot of reviews from the reviewers that, team recommendation may not be part of the information retrieval. So you may ask, what's the relationship between the team recommendation and the information retrieval? So I have to ask you to be patient, and then through this slide, I will explain the relationship. This is one note. Another note is that I'm going to use a lot of still images from movies, and hopefully you are a movie fan, or at least you see some of these movies. These are the great movies in the history of cinema. So then you can connect the topics that I'm going to explain with the movie. So this way you can memorize or you can remember the topic. So this is the movie Eternal Sunshine of the Spotless Mind by Godfrey, 2004. And how many of you have seen this movie? No? Okay. This is a good movie. I highly suggest you to watch this movie, at least, the coming weekend. Let's just start. So I have a very small research group in Canada, University of Windsor, in Windsor, Ontario. And these are my group. And actually, Matthews directly flight from Windsor to here, so from the west part of the Canada, but I have to be in Dubai and then come here, so basically we did the whole circle to the world. The organizer for this specific tutorial is Matthews. Majority of the topics going to be covered by Matthews. And then my undergraduate student, Christine, she cannot make it for today's tutorial because of the time zone. So we asked another master's student of mine, Daniel, to be here to do the hands-on coding. And then finally, myself. And this is the outline. So basically, for the first 20, 30 minutes, I'm going to explain about the background, what is team recommendation, how can we define success. And then after that, as I said, majority of the topics are going to be covered by Matthews. And finally, we're going to have hands-on experience on our benchmark library, which is how can we form a team, how can we train a model to recommend a team, and etc. So this is my part, introduction and background. So the main terminology or the main term in team recommendation is the word term. So we have to define what is term, team. So basically, this is a definition 1997 from psychology. Basically, a group of people who can collaborate in a way that they can move toward a success, a common success or common purpose is called a team. So these users could be students, could be online users, could be any experts, or they could be actor or actresses of a movie. So based on the domain, this group of people can change. But the main thing here is that they should be able to do collaboration. So there is a difference between team and a group, and I'm going to emphasize on that. This is another definition. Sometimes we form a team, the members of a team can be assigned different independent tasks. So you think that, the tasks are not dependent on each other, so as a result, they are not team. However, we know that independent tasks can be a part of a puzzle in a way that we can put together to form and complete a task. So a team can, the members of a team can work independently. However, However, finally their outcome gonna go for a shared goal. This means that the team members should be adaptable and they should interact with each other efficiently. So these are just formal definitions, but usually for myself, my learning is usually through images and movies and etc. So in these two images, I try to make a contrast. What's the difference between a group of people and a team of people? So in the left side, we can see that this is just an image of a nightclub, a group of people that are just enjoying their time. But you can see that there is no shared common goal. They are not going to be successful in doing something. So this is not a team. However, in the right side, you can see that there is a task, basically moving a sofa to the small apartment through the window because it cannot be done through the door. So this is a goal. And you can see that there are different peoples, women, men, also different age groups, for instance, senior person, adults. And one thing is that they don't have same set of skills. So for instance, one of them is just observing, another one can simply lift another person, and etc. So this picture to me shows the actual teamwork. I mean, different levels of expertise, they can collaborate toward a success. So in contrast to the left side, that I mean, there are majority of them from the same age group, and there is no goal, and etc. So the right side is actually visual definition of a team. So what are the instances of team in real world? One instance we can observe is in education. So in education, it has been proved that if the students are part of a team or part of a group, they can learn more. So basically, we all experienced COVID, and we see that the students join online, and the educational performance actually downgraded because the students couldn't work together. So this is an instance that team recommendation can find application in grouping students to work together to learn how to collaborate and be successful. So this application gonna be discussed more by Mahdiz. Another instance is this. So in research, basically we are in the computer science conference, so we know that majority of the computer science publications are multi-author, meaning that they are a group of researchers, they work together in order to publish their research. Although there are some researchers that they insist to publish and do research individually. So one of the instances is Yusuf Derbal. As you can see, he always published single author papers, he always do the research alone. But this is very rare. So in majority of the research groups, you have a group of researchers to do the research. So this is also another common example of teamwork. Another example, very important example, basically because of the, the money investment in that, is the entertainment industry. So for instance, if a producer wants to produce a movie, that producer is looking for the best actor, actress, directors, and cameraman, and etc. So in order to build a successful movie. So as a result of, this is also another important application of team recommendation. So how many of you have seen this movie? I'm going to explain this because these examples, some of them initially when they're released, nobody has seen them and nobody paid the money to see that. So they had failure in box office. But within the history, people gradually start watching these movies and they become successful. So this is the one of the top cult movie in Western countries. So majority of people there has watched this movie. So another important application of a team is sport teams. So for instance, in soccer, in basketball, in any team-based sport, we have a team, we have to define success, and this is the Women's World Cup 2011, so you may know this for sure, yeah? So this is another instance of team, and there's a lot of research on how to form a optimum sport team. So, so these were the instances of the teams in real world. Now we want to see that if you want to form a team from scratch, what are the steps in order to guarantee that that team becomes successful? So again, it's a very old study by Tuckman, 1965. Basically, the distinct phases of a successful team has been defined, and this is referred to as Tuckman model of team. So the first step is forming. Basically, a team leader or project manager wanted to do a task, so that person is looking for people. And this is a short period of time, so just among the available candidates, tries to find a subset of optimum people to do the work. And then after the forming of a team, we have the storming. So the storming part is basically, you may basically experience this when you were doing the school projects, I mean in 2 or 3 students, and you see that when you form a team, after that you want to start the project, there are some conflicts. Some students say that I don't want to do this task, I don't want to do that task. Some students wanted to change the project goal. So this is called storming. So there are many conflicts between the team members, and the reason is that the students or the people are from different backgrounds, different personality traits. Some are lazy, some are very hyperactive. So this is called storming. But after the conflict has been resolved, and then finally everyone goes on the same page and understood the goal, we call this norming. And at this step, we see that all the team members understood everything, and they are ready to move toward the goal. And then finally performing. So they define the task, subtask, sub-subtask, and they start doing the task toward the final outcome. So, but team recommendation specifically talks about the first step, forming. Because this step is very important. If you try to form find the optimum people, and optimum people doesn't mean the best people. So, the study shows that if you find the best people, it's not a guarantee to success. So usually there should be some people with less expertise, high expertise, so a combination of that. So in this step, if you could find an optimum team, the other steps gonna be smoothly move on. So that's the very important part. So now let's back to the original question. So what's the relationship between team recommendation and information retrieval? Why we provide this tutorial in this conference? So the thing is, there is in 2010 in the AppDapp conference, Horowitz et al., they provide 2 visions to the information retrieval. So the first vision basically is based on finding the information need in a library. So basically, all the majority of search engines like Google, Bing, and etc., they originally founded based on finding information from books in libraries. So this is called library vision to the IR. Another one is, so this is one vision. So web search, all the search engines and everything like this is based on the idea of information retrieval in a library. But the second vision that they proposed was this, social search. This means that they proposed a social search engine called Aardvark, and the idea is that instead of just looking for the information from the web or from the documents, finding the relevant information, try to find a person who knows the information. So this vision is called a village. So basically you go to a village, you are trying to find the person who knows the map, who knows the area, who knows the information. Based on this idea, there are some information retrieval methods called social search. We are trying to find the people. So in this way, team recommendation is social search, meaning that we are doing social information retrieval or social IR. We are trying to find the best people, optimum people to do a task. So we are not looking for relevant documents, but we are looking for relevant people. And that's why there is a strong connection between IR and team recommendation. So now that we know this connection, in web search, we know that some document may be relevant and it satisfies the information need. But in team recommendation, finding the relevant people is not enough. Those relevant people should work together toward the success. So we have to define another terminology called success. So what is success? In some domain, success kind of very trivial. For instance, in sport, you can simply say that the key performance indicator is just winning the cup. So if the sport team wins the cup, definitely that's a success. However, even in this domain, there could be some controversy. So for instance, what happens if a country sets the goal up until just second place or third place? So do you consider that as a success for that team or no? So, but again, in sport teams, usually because it's binary, win or lose, so it's very simple to define success. But in other domains, it's kind of difficult. For instance, one of the common, as I said, application of team recommendation is in movie. So assuming that a movie basically could sell, or it becomes the top box office in the world. For instance, the Barbie. How many of you have seen this? No. So also myself didn't watch it. So in this movie, basically, the box office was $1.4 billion. But however, this movie didn't get any Oscar. So this means that from the budget perspective, from financial, it was a success, but from the critical reviews, it was a failure. So again, I mean, based on what you define the KPI, key performance indicator, the success is going to be different. And another interesting thing is this. So how many of you have read the paper Word to Vec? You are in IR, so most of us know the Word to Vec paper, yeah? By Mikolov and Jeffrey Dan. So there is a nice history behind this work that, I mean, they submit this paper to ICLR conference in 2013, and it got rejected. And not only in this conference, in other conferences, it got rejected. And they decided to release it in archive. So if you consider success for a research as a publication, that was a failure because it couldn't be published. However, after 10 years, in 2023, this paper, they invited to submit it to a journal, it got accepted, and after 10 years, it won the Time Award from NeurIPS. So it took about 10 years, then we can measure it as a success. So again, in science, what would be the success? I mean, the publication, or the citation, or what? So this is also another challenge. But for most of the research work, like our work and also the literature, they go with a simple definition of success. For instance, if they wanted to train a model or provide a computational model, assuming that as long as a paper is published, it's a success. So if there's a patent means that a bunch of inventors try to invent something and they make an invent and it's submitted to the patent office. As long as that patent becomes issued, it means that that invention was successful. In software domain, as long as a group of developers could release a software, a version of software, you could consider that as a release. In GitHub, you can consider the stargazers of a number of forks, different metrics to measure the success. But again, very minimum measure of success could be just releasing a software. In movie, as long as it is produced and it is in the theaters, it is a success. So this is just a minimum bare definition. So now, let's see the hands-on experience on forming a team. Assuming that now I want to form a team in a way that do a research and this publication become accepted. So traditionally, it was just manual. So basically, even right now, I try to find my student myself. So there's no machine to help me to find the students, yeah? But this is very tedious, error-prone, and suboptimal. Why? Because right now we have billions of candidates, so we cannot, search over these billions of candidates manually. Another one is this. So these people are coming from different cultures, different backgrounds, so I have to do, personally, I do 2 rounds of interview with my students just to get to know these students, so it takes a lot of time. Another thing is that even myself, everybody has some hidden biases. So racial bias, gender bias, or popularity. I may try to find the best students, but usually, again, from my experience, my deal with business students are very difficult. Usually the average would be nice, but best students or star students find it very difficult. So these are the hidden bias that we may have. Another thing is this. What about if I have a limited budget? If I wanted to hire some students or some people, but that person is not available, time constraint. So how can we consider all these factors to form a team? So by a person, it's basically manual. Forming a team is impossible, almost impossible. So that's why in the literature there are some methods. At least they are helping you to, filter the candidate expert for your team. And this is the hierarchy. So you can see that in the right side there are some non-computational. They are more about psychology of the information and etc. So there is no mathematical or computational model. But in the left side there are some computational models. You can see that originally it was search-based and OR-based, and Matt is going to touch on that a little bit more. And then nowadays, since 2019 and 20, there is a move to from the subgraph optimization toward the neural models and machine learning. And this is the time map. Within the time. So you can see that up in 2009, it was the start of the subgraph optimization to find the optimum team. Up until sometime 2019, mostly it was subgraph optimization, mostly OR, operational research-based methods. But because they are based on the searching entire available space or entire graph, they were computationally prohibited. So basically, they proved that it's NP hard, so it's not practical in larger scale. And as a result, there's a new move toward the machine learning-based models. So basically, if you have a collection of teams, you just let the model learn the association between the skills, experts, and the success. And the thing is, these are called learning-based methods, and you can see that since 2020, it has been started, so it includes the GNN methods and neural architectures. But one thing here is that I just want to make it very clear that the main idea of this tutorial is this. So there's a huge amount of research on graph-based optimization. But learning-based is just new. So, and the way they define the learning-based method is just based on a normal classification or multi-label classification. So the idea here is that can we promote or can we motivate you to start research on this domain in a way that we use the knowledge from the subgraph optimization for neural architectures. And that's the main takeaway of this tutorial, if you could motivate that. And that was my last slide, and now Matt is going to start. Before that, any questions? Anything that